when you're watching a live broadcast of like a massive concert or the Super Bowl, and you expect the picture to just be flawless. You see the sweat on the quarterback's brow, and it just works.
Yeah, we expect this instantaneous pixel-perfect transmission, but we rarely actually stop to think about the physical reality of getting that image from, say, a camera on the field all the way to your screen.
Right, and that physical reality is honestly a logistical nightmare.
Welcome to today's deep dive. We're looking at some technical specs from HDTVSupply for this very specific piece of professional beer. It's the AJA FiDO-R-MM receiver.
So the mission here is to kind of uncover the hidden heavy lifting tech that makes these massive live video broadcasts possible, without dropping a single pixel.
Because the core problem a device like this solves is, well, distance, right?
Exactly, yeah. Pushing high-quality, uncompressed video signals over immense physical gaps is just incredibly difficult if you're using standard copper cables. Because trying to push an electrical video signal through miles of copper is, it's a bit like trying to shout a complicated message across a windy football field. The further the sound travels, the more distorted it gets.
Right, you lose the details. And that is exactly where fiber optics come into play. Instead of electricity, fiber uses light.
Oh, right.
Yeah, so this specific fiber optic tech allows for cable runs of up to 700 meters. That's almost 2,300 feet, using high-grade OM4 fiber cables.
Wow, 2,300 feet.
Yeah, and about 300 meters on standard OM3 ones. Light travels through that glass with virtually zero loss of quality.
So instead of shouting across a windy field, you're using like a laser pointer to flash Morse code in the dark. As long as you can see the light, you get the pristine message no matter how far away you are.
That's a perfect analogy. And that mechanism is also exactly why fiber optics completely eliminate what engineers call ground loop problem.
Ground loop problems, like electrical interference.
Exactly. In a massive venue with cameras and screens plugged into different power sources all over the place, electrical interference is, well, it's almost guaranteed.
Oh, sure. That makes sense.
But because fiber cables use photons instead of electrons to transmit the signal, they are totally immune to that electrical noise. The signal stays perfectly clean regardless of what the stadium's power grid is doing.
Okay, but you can't just plug a beam of light into a television monitor. Like, how does that high-speed light signal actually become video again at the end of that 700-meter run?
Well, that is what the AJA FiDO-R-MM does. It's a one-channel multi-mode LC fiber to 3G-SDI receiver.
That is quite the mouthful.
It is, yeah. But basically, it uses a photodiode, which is a tiny sensor that acts like a translator. It reads those high-speed flashes of light and converts the photons back into electrical pulses that a broadcast truck can actually understand.
And it translates it back into standard professional video formats, right? Because the source mentions it outputs to dual matching SDI connections.
Yes, exactly. So whether it's standard definition or heavy high-def 3G signals, it handles it. And crucially, it keeps all the metadata like HDR or high dynamic range completely intact.
Wait, okay, I have to stop you there because I saw the price. It's $905 for a converter. I mean, you can buy a consumer HDMI over fiber adapter for like $50 online. What makes this little box worth almost $1,000?
Right, I get that. But it comes down to zero tolerance reliability. If your $50 adapter flickers during movie night, it's annoying.
Yeah, you just unplug it.
But if this flickers during the Super Bowl, you lose millions of viewers. You are paying for incredible engineering density here. This device is only 4.6 inches long, weighs just half a pound, and draws a maximum of 2 watts of power.
Half a pound. That is incredibly small.
It's tiny. And it handles massive data rates, from 150 megabits up to 3 gigabits per second without breaking a sweat.
So it's format agnostic, essentially.
Totally. It is specifically designed to be jammed in crowded broadcast trucks or, hidden behind sweltering equipment racks. You can even mount it right onto a heavy camera rig.
And the source mentioned it's backed by a 5-year warranty, too. Plus, they specifically highlight the customer support from HDTVSupply reps, like Rachel and Mike.
Yeah, because in live broadcasting, failure simply isn't an option. Having that reliable support is huge.
Wow. Well, the next time you watch a flawless live broadcast, you'll know there are these tiny half-pound boxes working tirelessly behind the scenes to bridge massive physical gaps.
It really does shift your perspective on the invisible digital infrastructure surrounding us, doesn't it?
It absolutely does. And it leaves me with this thought for you to chew on. If a tiny 2-watt device can flawlessly process 3 gigabits per second of uncompressed video metadata across 700 meters of fiber, what other invisible, everyday digital bottlenecks are just waiting to be solved by miniaturized fiber optic technology?